well, let's think about this. We still want to apply the f over n rule. What's n? Has that changed? No? And f in words is what? The number of hands that... The what?
The number of possibilities?
Right, that, but what defines it? The number of hands that
Could meet
constitute four of a kind. Yes? The number of hands that you can get that constitute four of a kind. So let's walk this through. How many different kinds are there? 13. How many do we need? One. Just one. So we're going to choose 13 from one. Now, from the 4 cards in that kind, how many do we need? All 4. So this is just 1. So is that the answer? 13 over 52, choose 5? There's a 5th card. Right? That's right. So there are 48 cards left over. And it could be any one of those. So actually, that's exactly right. So out of the 48, you need to pick one. So really, it's 13 kinds, or 13 times 48 is the number of possible hands that constitute a 4 of a kind. Questions on that? How about a flush? All cards of one suit. It's still 52 choose 5 down here, right? How many cards, how many hands exist that constitute a flush?
13 choose 5? 9?
13 choose 5, so out of the 13 cards you have, you need 5. But that would be the probability of, say, getting a flush in spades. Times 4. There are 4 kinds, 4 suits. You choose one. Out of the 13 cards you now have, you choose 5. So when you multiply these together, you get the possible, the total number of hands that are a flush. Yes?
These all assume that nobody else is playing, right? Nobody else
Actually,
is
as
getting
long
a
as
card.
you're just sitting down and you're getting 5 cards, it doesn't matter if there are others playing, as long as you just look at your cards at the end, right? So before anybody gets a card, these are the probabilities that hold. But you're right. I mean, it changes if there are, say, a very large number of people playing. It changes if you have more decks. It changes if you have jokers or anything wild or any of that. Okay, so to see if this all is starting to make sense, let me know what the probability of getting a full house is. A full house is 1 3 of a kind and a pair.
So I think it's probability getting 3 of a kind, which would be 4 over 3. 3 of 4.
Yeah. So you don't want me to write that. What is it you want me to write?
Let's see. I don't know. I don't know how to explain it, I guess,
Was
the terminology.
4 and 3 and 4 and 2, right? Over 52
Here?
and 5.
Well, okay, but let's do this one step at a time. You're still going to use the f over n rule. Has n changed?
No.
Okay. So this part's okay. So what you're trying to do is count the number of ways you can get a hand that happens to be a full house, right? Okay, so take it one step at a time. I think your thinking was on the right track. First you need to pick one kind. How many ways can we pick a kind? 13, and we need to choose one of them.
13 choose. It's not kinds, right?
Now, if you've picked
We're
one,
not doing kinds, right?
what's
It's full
that?
house.
We're doing a full house. You've picked one kind. How many cards do you need from the 4? You just select 3, right? So 4, choose 3. So now you have 3 cards on your hand. How many cards does that leave you? 2. You still need 2 more, and they have to be a pair. Yes? Exactly. Exactly. So now you've got 12. Choose 1. And out of the 4 cards you've now selected, you need 2. Good. All right. Do you want to do 3 of times as well? Or are we done? We're trying to gauge it so that there's enough for you to go on to get thinking, but not so much that your brain starts bleeding.
Could you do one more?
Sure.
Thanks.